Let's take a look at another problem where we're given the key features and we want to do the graph. It says a person's happiness can be affected by temperature. Notice this time our graph is going to be nonlinear. That shows the happiness of a person's as a function. The happiness is y and the temperature is x. I want to interpret the key features. Notice I got some positive and negatives here. It's positive between 25 and 89, and it's negative for temperatures less than 25 and greater than 89. It's increasing for temperatures less than 57. It's decreasing for temperatures greater than 57. I've got a relative maxima at 57 when a person's happiness is about 85. So the biggest I'll get for my happiness is going to be 85. So I'll make my graph here. And they didn't say too much about how negative I have to go, so I'm just going to guess about right here. And when I look at this, notice the difference when we're going from negative to positive. Okay, less than 25 degrees, greater than 89 degrees. And then between 85 and 89 is when it's positive. In other words, 25 and 89 are my x-intercepts. So I better label my graph here before I forget. So I'm going to put my temperature down here, and I'm going to put my happiness here on the side. And I know my biggest happiness is at 85. So I know I'm going to put 85 up here. That's going to be my biggest happiness. And then when I look at my temperature, I think I'm going to start at 0. I could actually go to the negatives here, but I'm going to start at 0, I think. And it's negative at 89, so I think I'll count by 20s. So here's 0, 20, 40, 60, 80. I'll put 100 in there just to be on the safe side. And I'll have 0 here and maybe negative 20 here if I need that. Okay, next, so I'm going to plot my x-intercepts, which I know are going to be at 25. And by the way, we're sketching. We're not being super accurate here. And 89. And then I know my maxima occurs at 57 degrees. I'm up here at 85. And anything, when it's negative, anything less than 25 is going to be negative. Anything greater than, what would we say, 89, that's going to be negative. And then I've got a relative max here, so it's going to look something like that. And like I said, something like that. We're sketching a graph. We're not looking now. Let's make sure everything I have here makes sense as far as the key features, because I kind of guessed to start with, and there's nothing wrong with doing that. Okay, it's positive between 25 and 89. We did that part. It's negative less than 25. It's negative less than 89. So in other words, when you get cold or you get too hot, you turn grumpy. And then it's increasing for temperatures less than 57. So it's increasing for this part of the graph, and then it's decreasing for that part of the graph. And we got a relative maxima, and it's going down in both directions. So that seems like we have hit everything we need to hit for our graph. So you do a little guessing, a little checking, and then you verify it. Key, verify. That's what we're going to take a look at here. Now let's do another one. A little bit, notice each one we're doing gets just a tad more complicated each time. And notice this one, we have a lot more key features to worry about. So let's go through this question together. The number of people in line for a roller coaster throughout the day can be modeled by a function. So only one answer. We're going to use our key features to sketch a graph of our function. Then we're going to interpret the key features if x represents the time in hours, since the ride opened at 10 a.m., and y represents the number of people in line. So I know my graph is positive from negative 0.5 to 12. And how can time be negative? Well, we're counting the time before the roller coaster opened. So a half hour, I'm guessing, is when people are lined up. It's negative for anything less than negative 0.5 or 12. But once again, can people be negative? No. So my graph is really going to end at this point. I don't have to continue my graph less than negative 1/2 or bigger than 12. And so I think that's what I'll do to start my graph here. I will make my axis, and let me make sure I got enough room here because, oh, good. And I always like to have a light graph when I'm doing this. There's my y-axis. Here's my x-axis. And notice I have a negative 0.5 in here someplace. So a negative half hour. Now I haven't graphed very much here. Let's keep on going with my key features. I just stopped to graph this part so I kind of understand how to make my graph. Now let's keep on looking at what we're doing in the problem. Okay, it's increasing for x is less than 1.4. And it's increasing between 5.3 and 9.9, which means I'm guessing I'll have some, notice I got a relative minimum and a maxima down here. That will help me out. I've got intercepts. I've got an x-intercept at negative 1/2, 12, and I got a y-intercept at 220. And my end behavior as x increases or decreases, the value of y is going to decrease. So once again, I don't have to worry so much because I know what it has. Now, did I mention anything about a maximum at 448? So I think, maximum 643. Can't read very well, can I? Okay, so I want to, let's count by hundreds on my y-axis. So here's 100, 200, 300, 400, 500, 600, and 700. Now, let's graph our intercepts because those are pretty simple to graph. I'm going to put one at negative 0.5. And then remember, I'm only going up to 12. So, I don't know why I put that number in there. So let's go 1. Maybe I gotta count it by 2s. And there's my 2 x-intercepts. I have one y-intercept at 0 and 220. So here's my y-intercept. And then let's graph our minimum is at 5.3 and 133. And I'm going to redo that one because that's a little closer than I wanted to. Okay, 5.3 and 133, and then 9.9 and 643. Now we want to take a look. It's positive between negative 0.5 and 12. So in other words, I know my graph does not go below my x-axis other than at my intercepts. It's increasing up to 1.4. Did I have it? Oh, I have a minima at 1.4 and 448. I just realized I didn't graph that. So there's 1.4 and 448. And No, that's a maximum, isn't it? Sorry about that. I can't read. 1.4 and 440. So that makes sense. So I'm going to go up here to 448. That's my that's my relative max. And then after 448, what happens to my graph? Notice it's, let me highlight this for us here. It's decreasing from 1.4 to 5.3. Okay? So in other words, it goes like this, and it's increasing, and then it goes down to 12. Whoa. I drew too fast there. Okay, so because my graph, my program wants to make straight lines. So something close to that, right? And now let's go through each of our checks and make sure it makes sense. So from negative 0.5 to 12, that makes sense. It's negative less than that, but I didn't count those because you can't have negative number of people. It's increasing up to 1.4. That looks good. And it's also increasing from 5.3 to 9.9. That's good. It's decreasing from 1.4 to 5.3, and then after 9.9, it's going down. I know my intercepts are right. I know my minimum and maximum are right. And I know my end behavior, I really didn't show it, but it's going down each time. There we have it. That is probably the most complicated I think we'll come across today, where we just have to interpret all of our information to sketch our graph. We're not going to do any numbers or anything really complex or detailed on that.